Recording is rolling. It is Thursday, September 25th, Alex Day. You guys can work on homework 2.4, 2.5, 2.6 on Alex, which is due tomorrow. I'll walk around, help you guys out. And I do want to give you guys a pointer on one of these. It's, I think, number 21 or something close. It's one of the last questions. It was harder than I thought it was going to be. So it's one of these ordered triplets, like in 3D with three variables that has infinitely many solutions. Now, you would know that's the case if you get something like if you're using substitution or elimination, you get an expression like 0 equals 0 or 5 equals 5 or like some true statement where you lose your variables. Like, where's the x? Where's the y? What can I solve for? What that would mean in 3D is that they're like places where the planes come together, maybe along a single axis, where there's not like a single point. I'll show you guys what that looks like. Here in a few minutes. Right. But let's say you get something like that. Right. What you would do, how you're supposed to solve this to get the point in Alex is first eliminate one of your variables to get a relationship between the other two. For example, you can eliminate z to get y in terms of x. You might come up with an expression that looks like that. Hold on to that. Right. Then you go back to your expressions and eliminate a different variable. Let's say, for example, you eliminate y to get z in terms of x, and you get this type of expression. And then for the solution, ordered triplet, okay, again, it's not a single point, right? It'd be like a whole equation. So you leave one of your variables as it is. Now, in this case, I have everything in terms of x, so I'll leave x as just plain x. But you could type a whole expression in place of y and z, and it's not a single value. It's this whole expression. So in place of y, you go pop this expression there, pop this expression right there. So you type 3x plus 1 for y here, and 2x minus 5 here. Now I'm just making this up. I don't think that's probably an actual answer you get, but this would be the format. So you might get something like that. Again, I'll be walking around helping you guys out. So if you have trouble with that, let me know. I can help you out. Right. So also speaking of Alex, there was a homework open 1-1, 1-2, 1-3. Now this one you guys actually did on paper. That's what I actually gave you guys credit for. I opened it on Alex just so you can see kind of what the questions look like. I was thinking about it here. If you actually do this one also on Alex, which could be good review, right? If you do it by next Friday, October 3rd, I'll go ahead and put extra credit in the grade book for that. Right. Go back. Let's look at a 3D example, right? Because this follows from lesson 2.6. Now, the lesson 2.6, one of the first pictures I drew you guys was this 3D space. And I realized later that, okay, this is a little technicality, but I actually have the z-axis backwards. So if this is an xy plane here, there's something called the right-hand rule that mathematicians and physicists both follow. If you point your fingers in the direction of x and curl them in the direction of y, okay, your thumb will point to the direction of the positive z-axis, which in this case would be out of the paper. So I could call this negative z, that would be okay. Or alternatively, I could change this to y, or change this to z, or I guess this would be like some z value, this would be some y value, something like that. Right? So I could have an xy plane, and then z would be coming out of page this way. Right? So that could also work. Right? Now, what do these actually look like? Well, a couple of students yesterday in different classes showed me that Desmos actually can model 3D. So I can show you guys exactly what that looks like. I'm going to bring Desmos over here. All right, take a look. All right, so if you go to desmos.com, normally I just click on open graphic calculator. That's the 2D graphic calculator. But if you scroll down, look at this one. It says 3D. Ooh, I see something 3D going on. Big pink icon. You open that. Now, I did model, all right, three examples here. So to show you guys exactly what I'm modeling, I pulled them straight out of the book. And it's three that I did. Whoops, I have to switch the screen. Switch screen. Here we go. Okay. It's three that I actually modeled in lesson 2.6. So it's on page 119. So I'm on page 119. This is lesson 2.6. Number 4, number 5, number 6. Now, one of these came out with a single point solution, which is how they usually work out. That's number 4. And number 5 and number 6, one of these was no solution, and one of these was infinitely many solutions. And you'll be able to see from the 3D graph exactly which one's which. Again, I was trying to do my best to draw these in colored pencil the other day, but let's look what the actual computer model looks like for each of those. Right, so here's number 4. Right, again, I just copied it. I think I changed variables to x, y, and z, so it's the exact same picture. Okay, you can. Oh, look at that. Right, I can rotate. I can zoom out, zoom in. Right, there should be like a single point. You guys see those three planes right there? The green plane, the blue plane, the red plane. Uh, there's like a single point where they all converge. It's way down here. It's way down near the bottom of the picture. Okay. Oops. Okay. So I'm scrolling the wheel right now to kind of try to zoom in, zoom out. Okay. So there you go. I was trying to zoom out. You can rotate this, see what it looks like. Yes, so the solution is boink, this point right here. Okay. What about one day model number five? Okay, so go over to this one's number five. And you can see right away. See the red and the blue planes are parallel. That means that there's no solution. There is no single point where these three planes are all at the same place at the same time. So yeah, that one would be no solution. You can see it right there from those parallel planes. Yeah, the red and blue are parallel. And then number six, it was number six. Okay, you guys are looking at it right now. So yeah, type this here. I did want to point this out, is that one of your equations in number six didn't actually have the z, so you do have to click this box that says boink extend to 3D because z could be anything, right? Could z be 0 or 5 or 10 or negative 100? Yeah, it could be anything. So by checking this box, that allows for z to be anything. And you guys see that that green plane that popped up is parallel to the z-axis, right? Okay, but now what? Look at here, look at here. See how those three planes, they do cross each other, but not at a single point, but along the line. Ooh, okay. And that, in that case, that would be infinitely many solutions. Infinitely many solutions, by the way, is what this really hard one on Aleks is that I was helping you guys out with right here. That would be an example of infinitely many solutions where there's like a whole equation solution. Yeah. So I'll be walking around helping you guys with Aleks. Keep in mind, there's module two quiz tomorrow.